with the alkanes. We're going to start with alkanes, but before doing that, there would be a few things that I would be talking about, and they would be your basics. There's a thing called an electrophile. We'll be using this term very often. In simple words, whenever you see an electrophile is a species that is attracted to electrons. So it could be any species. It could be, the reason I'm using the word species is that it could be an atom, it could be an ion, it could be a molecule, it could be anything. Species that is attracted to electrons. And not only is it attracted to electrons, it can accept a pair of electrons, which basically means that it is electron deficient. It means that it needs electrons, which is why it is attracted to electrons. So what could be an electrophile? Electrophile could be a positive ion that is obviously going to be attracted to electrons, or it could be a partial positive molecule. For example, there is HCl, where H is positive and Cl is partially negative, so that is also attracted to electrons. Or it could be an electron deficient molecule. It could be neutral, like an AlCl3 molecule. Remember, we did in dative bonding that AlCl3 had an empty orbital. Aluminium had an empty orbital. So a positive ion, or a slightly positive molecule, or something that is electron deficient. So overall, something that is positive or something that is electron deficient, that's an electrophile. And in simple words, anything that is attracted to electrons, that's an electrophile. Then you have a thing called the nucleophile. Now, what's a nucleophile? As a nucleophile is the opposite. It's a species that is attracted to positive charge. The easy way to remember is that it's attracted to the nucleus, which is positive. So it's attracted to positive charge. Hence, it could be, uh, and plus there's another thing, and can donate a pair of electrons. Which means it has extra electrons, which is why it can donate a pair of electrons. So what could be a nucleophile? A nucleophile could be, it could be a negative ion, like OH minus one, or it could be a slightly negative thing, which is partial negative, or it could be anything that has extra lone pairs, like NH3. It could be neutral, but it has these extra electrons, lone pairs, which are attracted to positive charge. So anything that is attracted to positive charge, that's a nucleophile. ठीक है, is this clear? Abba, Rida, Heba, Minahil, is this clear?
Yes.
Actually, the third one is called a free radical. So what's a free radical? Now, a free radical is, again, it's a species. It could be anything. Take a molecule or an ion or an atom that has unpaired electrons. What unpaired electrons basically means is that its bonds are not complete. So if anything has incomplete bonds, that's basically a free radical. One example is a Cl atom, a Cl, and you put a dot in front of it. This is something that I'm going to talk about later. But let me discuss this right now. A nucleophile, I'm just going to put it as Nu. It's represented by two dots. Two dots represent that it has extra electrons, which is why it's attracted to positive charge. Electrophile has nothing, no dots, nothing mentioned. A free radical, on the other hand, has one dot. One dot means that its bonds are not complete. which is true in the case of Cl. Cl has an electronic configuration. The outer shell is 2s2, 2px2, 2py2, and 2pz is 1. So you can see that it needs an electron in its outer orbital. Its orbital is unpaired. OH could be a free radical. Uh, Oxygen's bonds are not complete. So all these are free radicals that have unpaired electrons that have incomplete bonds. A CH3 could be a free radical because carbon is supposed to make how many bonds? It's supposed to make four bonds. So the fourth bond is not there, which means the fourth electron or the fourth orbital of carbon is unpaired at the moment. So three things. So I'm going to keep on repeating these three words over and over again. There's going to be electrophiles, nucleophiles, and they're going to be free radicals. Something about free radicals is that they are very reactive. They're very reactive. And why are they very reactive? Because their bonds are incomplete and they need to make bonds. So they're going to react. So most of the time, free radicals are extremely, extremely reactive. Then another thing about another basics is there's going to be a thing called homolytic fission. Now, homolytic fission is when the bond breaks equally, right in the middle. So whenever you see a bond that's breaking equally, that's homolytic fission. For example, you have a Cl2 molecule, and the Cl2 molecule, one electron goes to one Cl, the other electron goes to the other Cl. So that results in the formation of free radicals, two atoms with incomplete bonds. So usually forms free radicals. Right? Is this clear? Imran, is this clear? Mazga, is this clear?
Yes, sir.
Yes, sir.
So that's homolytic fission. And the other one is heterolytic fission. Heterolytic fission is when the bonds break unequally and one of the atom takes away all electrons. So you have a HCl molecule and Cl takes away both electrons. And that results usually in the formation of ions. ठीक है, so H plus 1 and Cl minus 1. That's heterolytic fission. Bond breaks unequally. Now, another thing is curly arrows. Remember, mechanisms that you're going to study, they're going to be represented by these curly arrows. And the shape of the arrow would always be like this. ठीक है? So it's the movement of electrons. They show the movement of electrons. ठीक है? They don't show the movement of any other thing except for electrons. So a full arrow would represent movement of two electrons. Full arrowhead. So that represents the movement of two electrons. And then you have a half a arrowhead. That's half arrowhead. That shows the movement of one electron. So it shows the movement of one electron. ठीक है? Is this all clear? Homolytic fission, heterolytic fission, curly arrows, electrophile.
Clear.
ठीक है. चलो. बाकी is this clear? So, now we're going to start with alkanes. Starting with the very first thing, which is we've already done what alkanes are. How do you name them? TK, we've done all of that. Uh, so alkanes are saturated compounds. So they are saturated hydrocarbons. Plus, as they are saturated hydrocarbons, what are their physical properties? They're non-polar, which makes them having. I mean, they're going to have van der Waals forces only. I mean, there is no polarity. Carbon and hydrogen bonds are non-polar, and because of that, they're going to have low melting and boiling points. Plus, they're also going to have. They're not going to mix with water, so they're going to be insoluble in water. They can't form hydrogen bonds, so they will not be interacting with water molecules. So no hydrogen bonds are formed by alkanes. One property about all organic compounds that we studied was that if the molecule size increases, the melting and boiling point also increases, and the insolubility in water also increases, and the viscosity increases, and the flammability decreases. Because early on we did this that the physical properties, if the size of the molecule changes, the physical properties also start changing. So these are the two main things: low melting, and obviously they don't conduct electricity. And because of this non-polarity, they're going to be they're very unreactive. Simply because they're non-polar. For example, if you have a methane molecule and there's a now methane is mostly non-polar, so there's an HBr molecule which is polar. They would not interact, no attraction. I mean, there's no specific attraction between them, which is why the methane molecule is going to be very unreactive because it's non-polar. Okay, Ibrar, Abaz, is this clear? Minahil, Abba, is this clear?
Yes, sir.
Clear.
Yes.
So they're very unreactive, and they undergo usually just one reaction, which is known as the chlorination or bromination reaction, which you studied in O levels. So there's chlorination happening or bromination. Now reactions, remember reactions with fluorine are too explosive, and with iodine the reaction is very slow. So we don't usually talk about them. So with F2, very explosive, and with I2 the reaction is too slow. So it's going to be very slow. I say, anyways, chlorination and bromination that you studied in O levels, it was the proper name for this is free radical substitution. So that's the proper reaction name or the mechanism name for this reaction. It's called free radical substitution. What happens in this reaction? What you studied in O levels was that you take a molecule of let's say methane, and you react it with Cl2, or so now there's going to be UV light involved, sunlight, and one of the hydrogens or all of them might get substituted. So it's a completely random reaction. You don't know how many hydrogens would be substituted at what positions. Plus HCl would be produced along with a chloroalkane. So chloroalkanes are produced, and this is a simple reaction, and HCl is going to be produced in this reaction. And the same with bromine. But ultraviolet light or sunlight is always needed. Okay, so this is what you study in O levels. Now the mechanism of the reaction. This is what is going to be there in A levels. Now the reaction is kind of very complicated. It's not as simple as this equation tells you. Okay, what the reaction has that the mechanism of this reaction is divided into three steps. The first one is known as the initiation step. Okay, that's step number one. And remember, the steps are really not in any order. But this is, I mean, without this step, no reaction would be possible. No substitution reaction would be possible. Now, in this first step, what happens is that free radicals are formed for the first time. So you have a Cl2 molecule, and because of UV light, the bond breaks homolytically. So I'm going to draw two curly half arrows. And this happens why? Because there is UV light. The UV light helps in breaking the bond. So the Cl bond breaks, and two free radicals are produced as a result. So there's a Cl radical and there's another Cl radical, and Cl radicals are very reactive because they need to complete the bonds. They need electrons to complete the outer shells. ठीक है, is this clear so far? Rida, Hiba, is this clear? Minahil, is this clear?
Yes, sir.
So that's the first step, initiation. ठीक है, so this is happening, and what's the next step? Step number two. That is known as the propagation step. Now, the propagation step is that uh, total number of free radicals in this step they remain the same. So total free radicals total number of free radicals they remain the same. Now, what happens now? This step is the complicated one. Like you have a methane molecule. The Cl radical is going to attack this molecule. Why would it attack the molecule? Because it needs an electron. Cl's outer shell is not complete. And Cl is highly electronegative, so it can pull electrons away from other atoms. So there's hydrogen with its electrons bonded to carbon. Cl is going to come along and it's going to steal or pull that electron away from carbon. And carbon, I mean, this bond would break. So carbon would get its electrons back. So H, instead of sharing electrons, so what would H do? H would, instead of it's sharing its electrons with the carbon atom, Cl is going to come in, and Cl being highly electronegative is going to pull those electrons away from carbon and steal those, and it would form HCl. So that's how HCl is getting formed in this reaction. So in HCl molecule, as an HCl molecule is produced, but what's left is that it's carbon with an H missing, and that carbon then forms a radical. This is known as a methyl radical. ठीक है? Bhaskar, is this clear? Minahil, Hiba, Aba, is this clear?
Clear, sir.
Yes.
Achha, now when you're asked to draw this, you would have to draw the arrows exactly. I mean, the whole thing has to be drawn exactly the same way. Okay, you have to be very careful with the arrows. Everything. There's only once. that I remember that this mechanism, specifically this one, there's another mechanism which is more popular, but this mechanism is I've seen it once or twice only. So usually you don't get questions on this, but it has come in your exams to draw the whole mechanism. As anyways, you have a methyl radical now. What would the methyl radical do? Now it needs electrons because its bonds are incomplete. So any radical that's very reactive, any radical that's formed or exists, that it's going to be very reactive because it needs an electron. Carbon needs a fourth bond. So it sees a Cl2 molecule that's already breaking. I mean, the Cl2 molecules are already breaking up in the UV light. So because of the UV light, the Cl2 molecules are breaking up. So the H attracts electrons from one of the Cls and ends up bonding, and this other electron goes back to the Cl. So the final thing that's formed is this C and H and H and H, and the Cl has now come and attached with this, and the Cl radical is again formed. So this is reformed. Like you started with Cl radicals, and at the end of the day, the Cl radical is still there. So, but what has happened is that one of the chlorine has gotten substituted in the methane molecule. Now it's a chloromethane molecule. Okay, is this clear? Ibar, is this clear? Ibrar, is this clear?
Yes.
Now this step can repeat many times over. What you're going to do is the only thing that you need to do is, I mean, repeat until all hydrogens are substituted. So keep repeating these. Um, so repeat the same steps, same two steps. The only thing that you're going to do now is that one of the Cl is already substituted. So draw everything exactly the same, except that one of the Cl is already there. So one of the Cl is already there. So instead of CH4 starting with CH4, you start off with one Cl that has already replaced or substituted, and start repeating. So the Cl radical attacks again. The H, instead of bonding with carbon, starts bonding with Cl, its electrons, and exactly the same thing happens. Then you have a CH, and Cl radical is formed, and an HCl molecule is formed. So it's basically the exact same thing, except that there's one Cl that's already there. So that's the first step. This is known as a chloromethyl radical. And repeat the second step now. You start off with the chloromethyl radical. Now it needs its electron back. It sees a Cl2 molecule and it attracts electrons from Cl and bonds with it. So it's going to be CH and Cl, and another Cl has been substituted, and the Cl radical is again present at the end. So it's exactly, these two steps are exactly the same, except that just put a Cl already there. The next step is going to repeat. Now the Cl radical is going to attack another hydrogen. Like two Cls are already substituted, so it's going to attack the other hydrogens. Okay. So do you get this point, Ibrar?
Yes, sir.
Rida? Okay. Binail, is this clear?
Yes.
So it's going to keep on repeating. So just imagine I mean, you can just picture this same mechanism with three Cls. There would be three Cls over here. There would be three Cls over here, and in the last step, there's going to be four Cls. Like in the last step, if you have three Cls, another Cl goes and attaches. So you can just keep on increasing the number of Cls in this molecule, and you're going to keep on getting steps. Now, the very last step of this entire mechanism is known as the termination step. One second. So that's the very last step. That's known as your termination step. And remember, it's actually not the last step. This step could happen at any point. At any point, the reaction could terminate. Termination is that any two free radicals, they can bond together. For example, there's a Cl radical. I mean, you have all these radicals being formed in the propagation step, in the initiation step. You have lots and lots of radicals that are forming. So let's say there's a Cl radical in the first step. I mean, you don't have one molecule. There are thousands of molecules, and there are thousands of times this reaction is happening. So there could be a Cl radical coming from the first step, initiation step, and there could be a CCl, this radical that could be coming from the propagation step. So if they two see each other, they both need a bond. So why don't they just combine together to form a bond? That's it. And that would terminate the reaction. So any of the free radicals, any of the random free radicals that are being formed in the previous steps, they can simply combine up, join up, and they can form a molecule. Similarly, you had a methyl radical, and there could be another methyl radical that might be somewhere else, and they can probably get together. They both need one bond, so they can get together and they can start sharing electrons, and they can form an ethane molecule. That would be the ethane molecule. So in this way, you could have many many different possible uh, termination steps. There could be a CCl3 radical and a methyl radical, like different propagation steps, and they could probably join up, and that would result in the formation of this molecule with three Cls and three hydrogens. Okay, so number of possible products could be produced in the termination step. So it's a completely random reaction where the only thing for sure is that the hydrogens are getting substituted by Cl. But even the number of carbon atoms in the molecule, they're increasing. Like you started off with methane. I mean, the first molecule was a methane molecule, right? In the propagation step, you started off with methane, but at the end of the termination step, two methyl radicals are getting together to form an ethane molecule. So you can get bigger molecules in this reaction. Is this clear to everyone? Rida, is this clear? Mazga, Ibrar,
Yes.
Abba, is this clear? Achha, so there are multiple possible products that are possible in this reaction, and you must be able to visualize what products can be formed in a reaction. Uh, so initiation, propagation, and termination. So let's try an exercise without actually drawing the. I mean, you don't have time. Like in the exam, you don't have time to draw, unless they ask you for a very specific step. You really don't have time to draw these steps. So, for example, they are asking. I mean, there might be a question that there is butane free radical substitution of butane. Okay, let's talk about propane. So there's free radical substitution of propane going on with bromine. Now the question is, um, what products can you obtain? For example, somebody says that this is a product of free radical substitution of propane with H's, and I mean there would be three CLs, right? H. Acha, can anyone tell me whether this is a possibility or not? If you're doing free radical substitution of propane, any idea? Bazga, any idea? Ibrar?
Sir, on the left it's Cl or H?
CL. I mean this is CL.
No, it can't be.
Just one second.
Sir,
हाँ, Ibrar. Abba, any idea? Yes, Ibrar.
sir, आपका क्वेश्चन क्या है? सर आपका क्वेश्चन क्या है?
If you do free radical substitution of propane with bromine, अच्छा, sorry. Bazga is right. I'm doing it with bromine. Okay, so let me put bromine over here. Anyways, the question is whether this molecule is going to be a product of the reaction or not. Free radical substitution of propane with bromine.
Yes, yes.
Okay, it's going to be a product. Why? Okay, this is
Chlorine is more reactive than bromine.
really not about that. I'm just saying. I mean, there is no chlorine right now. Okay. What I'm just saying is,
अच्छा,
what I'm just saying is that I'm starting the reaction with propane. Propane is this thing. Now this is propane. Uh, what's happening is that you're having free radical substitution with bromine. So in the first step, initiation, bromine radicals would be produced, right? And that is what happens. Like over here, even this is exactly what happens. In the first step, free radicals are produced because of UV light. And I've told you that the reaction happens with chlorine as well as bromine. You're going to have the same reaction with bromine. So what do the bromine radicals do? Like without even drawing the curly arrows, the bromine radicals are going to steal one of the hydrogens from this molecule, right? So let's say the molecule, the hydrogen at the end is stolen. So what would be formed? An HPR molecule would be formed, and this would form a free radical. Is this Ibrar? Is this clear? Minail, is this clear? Abba, is this clear?
Yes.
Yes.
Okay, so the bromine radical is going to come in and it's going to steal any of the hydrogens, and the process would continue. Like this propyl radical that is produced, it would then try to steal a bromine molecule in the propagation step. It would try and attach a bromine atom to itself, and the other bromine would take away its
Sir,
electrons. And
this is basically the termination step, right?
nee, this is right now. This is the propagation step.
No, then what was the termination step? I mean, it was the same thing, wasn't it? Where the two radicals were bonding.
Two radicals were bonding. Just one second.
Oh, I mean the question you asked, not this one. This is propagation. The
This
question
is
that you asked.
propagation. Nee, the question was totally different. Okay, I was just asking, okay, whether this is possible or not, right? That was the question, right?
Yeah. So
Achha,
what
so I've
has
drawn.
it got? Yeah, has it got anything to do with the termination step, the product that you just wrote above?
That product that is going to be made in the termination step.
Yeah, okay, that's what I was asking. Thank
Achha,
you.
this is your propagation step, right? I mean, after the initiation step, a radical is produced that steals one of the hydrogens, This forms a radical now because its bonds are incomplete. This goes and then steals one of the bromines and bonds to it. So bromine gets substituted. And this process keeps on repeating. Every time there's going to be one extra bromine over here. Okay? Nidaiba, is this clear? So what's happening is in the propagation step, you have all these free radicals that are being formed. And every time the propagation step repeats, there's going to be one extra bromine that's going to be substituted. So, for example, there could be another propagation step. Like every time there's an extra bromine getting added, then bromine radical comes in, takes away one of the hydrogens from somewhere else. So again, free radical substitution happens. I mean, propagation happens. So maybe in some other step, you might get this radical, a radical where three of the hydrogens have already been substituted. Okay, so further on, like if you keep on repeating the propagation step, you might get this. Is this clear? Abba, do you get this point? Rahel, is this clear?
No, sir, this is when the termination step is about to begin, right? When this free radical begins to react with another free radical.
नहीं, I'm not. I haven't reached termination. But उसी पे चले जाते हैं ना वापस के. What I'm saying is कि
Hmm.
every time the propagation repeats, ठीक है? Propagation is these two steps. Cl radical comes in, takes away the hydrogen. Methyl radical is formed. Methyl radical then attacks a Cl and pulls it to itself. The chlorine gets substituted. The same thing repeats. Cl radical comes again. One of the chlorine is already substituted now. It takes away electrons from some other hydrogen atom. So another radical is produced, but that radical now has a Cl in it. Okay? And if you keep on repeating this, the radical will have more and more Cls in it. Ibrahim, do you get this point?
Yes, sir.
So the same is happening over here. Like I did one propagation step. In one propagation step, one of the bromine got substituted. Repeat the same step again. Br radical comes in again and then attacks this molecule. It has all these hydrogens. It takes away an H from some other carbon atom, right? तो फिर वो radical बन जाएगा. So what basically happens is that this radical, the hydrogens keep on getting substituted. So this is one of the possibility that might appear when you're writing all the propagation steps. Okay? For example, for this there would be a lot of propagation steps. You would have to do it 1, 2, 3, 4, 5, 6, 7, and 8. 8 times. You have to repeat this 8 times. There would be 8 different propagation steps. Every time a Br radical comes in, takes away the hydrogen. Ibrahim, do you get this point?
Yes, sir, I do get this point, sir, but I have a question. Is it necessary for all hydrogens to be replaced, matlab in a propagation step, or because you said it's a random process,
Not
so
not
kabhi bhi-
necessarily. Not necessarily. I said that the termination could happen at any point.
yeah, exactly. So even if one hydrogen is replaced and then a termination reaction occurs and it stops replacing any more hydrogens.
Even reaction यहाँ तक पहुंचा, you just reach this point, termination could
Hmm.
happen. But you reach this
Right.
point, so there's Br radicals roaming around. The Br radicals could simply, instead of doing all of this, the Br radicals simply combine with this one. That's it, termination.
Oh, no.
Okay? So the propagation step doesn't necessarily complete. It just continues. So what I'm saying is, the last thing is, okay, these two can combine together in the termination step. Like the Br, there was this radical and there was this propyl radical. So different radicals are being produced and they could simply combine together. And if they combine together, they're going to form this molecule over here. Okay, think of this molecule. This was what the question was that I told you. Okay, whether this is possible, this molecule, is it possible in the free radical substitution of propane? Would you get this molecule? So the answer is yes, you can get this molecule. Is this clear or somewhat clear? Mirail, समझ आइए? Abhay, do you get this?
जी
Heba, Rida.
Sir, I get it, but I don't get where does that the other propane side, the other radical comes from. मतलब एक तो हमारे पास Br3 वाला side है, so
Huh.
where does this right side radical comes from? मतलब
Because in a reaction, you don't have one molecule that's undergoing propagation, right? Think of, मतलब इसको duplicate करो ना. Think of the thousands of molecules, billions of molecules of propane. And there's मतलब एक bromine थोड़ी है पूरे reaction में. There are lots of bromine molecules, right? So मतलब there's
जी.
a container in one corner. There's this reaction that's happening. In another corner, there's this reaction that's happening, right? And they might get together. Do you get my point?
Yes, exactly.
तुम्हारा यही
सही
क्वेश्चन
बात
था ना कि sequentially चल रहा है ना कि if you're going in a sequence, if you reach this point, there wouldn't be any propyl radical. That was the question, right?
है. जी जी जी, exactly.
So the point is that the reaction is happening multiple times at the same time with many different molecules.
ठीक है.
So every possible free radical is possible in the reaction, and they might get together at any point. ठीक है? चलिए ठीक है, we'll continue with this tomorrow then.
Allah Hafiz, sir. Thank you.
Okay, take care. Allah Hafiz.